before we start into this, I really need to know how deep you want me to go into NixOPS internals and stuff like that. Sun is shining, so you really need to tell me how extensive you want it to be.
All the way.
Very extensive. Okay, so my time ends basically tomorrow morning, 10 a.m. That's when the next talk starts. Up to that, I could keep talking if needed. I think Christina somehow figured out that I would be close to Munich anyway and got me in the loop about Nix. At some moment there was an email, and at that time I was suffering a lot. I tried to use NixOPS and I was running in a wall and was running through it, was running in the next wall, and I kept doing that a few nights instead of sleeping until I started to understand how this whole thing works together. So what I wanted to achieve was basically just use a NixOS container, get that deployed, because I had an application and I wanted to throw it somewhere and see how I could do this with NixOPS. I got a bit too excited and focused more on NixOPS instead of the application that I actually wanted to work on. But yeah, that's how it started, and that's also how I plugged together the different parts that you might see flying over the screen in a minute. Short introduction, I'm Johannes. The rest is known by Google. There's a Twitter handle. I think you can probably figure out nearly everything. So I also sometimes throw out a few notes into my blog. There's also a very old site about my company. The only thing which is still true is that I run my own company, but everything else is not up to date anymore. So much about myself. In my professional life, I'm a Python developer mainly. I also prefer to be called a developer, not anything else like senior, junior, architect, whatever. Because in the end, I think I develop software. And that's this. So, still up for so much detail? I'm nodding, oh my god. Okay, let's see. First of all, I need to know, I just wanted to ask, how much do you already use NixOPS? How deep are you in it? So would you like to get a very brief introduction or no introduction at all?
Introduction is
great. Okay, a little bit of an introduction. So that's how I understand it. So I'm not so much focusing on being fully correct up into the last detail. It's more like my way of how I look at it. For me, it's all starting in the base with Nix, the package manager. That's also how I learned about the whole NixOS community and all the different tools that we have there. And that's also basically the workhorse for NixOPS. Most of the work is delegated to Nix. It's basically building some derivations. From my understanding, on top of Nix, you can see NixOS. That's like the operating system. There's also a very extensive manual with like a super massive set of configuration options where you can basically say how you want your system to be, and then you can build that system, and that build is carried out by Nix again. So that's kind of layered. And NixOS itself has also some sort of container support. From my understanding, it's a very thin wrapper around systemd and spawn containers. So it's also good to be aware of that and understand a little bit. In the end, it's just calling systemd and spawn to run this container. And what then NixOPS does, from just my understanding, basically from a description of a network, it builds a set of machines. The build itself is again carried out by Nix, so there is nothing about how to build a derivation inside of NixOPS. It's just making use of Nix at this point, and it's making use of what we see in NixOS because the whole module system is there. So when I describe how I want the container to look like, I can basically use all these attributes to define that. So if you basically come through this route that you learn about Nix and you learn about NixOS, and suddenly you want to try out NixOPS, there's a good chance that some chunks of the stuff you basically recognize and you feel at home. So there's a chance of going in increments there. NixOPS itself, what it does is basically it carries out, it triggers the needed operations. It can manage a few resources for us. It has some different backends. So I'm focusing pretty much on the container backend now. There's also real cloud backends like AWS and things like that. There NixOPS can do a bit more, so it can basically provision resources for us which are needed when you want to deploy a network of machines. But when you think of the container backend, most of this stuff is not so relevant. What stays is managing state. When I create a deployment, basically NixOPS writes something into its database, and then I can carry out the operations. It's going to create a container for me, and it's updating its state database. So I can, inside of this database, I can see if a container is running or not, if it should be running or not. It doesn't tell me if it's physically running. For this, I would have to check on the host machine itself. And yeah, so that is basically how I see these things relating. So also NixOPS in theory, very simple, very tiny thing. In reality, for me, it was, don't know if it's due to NixOPS or if it's due to how I approached it. For me, it was very hard to get to a point when I had this feeling like, this is how it works. That took a while for me. About 3-4 full nights of heavy punching. So that is just the overview. I don't know when there are questions, just scream or start some other activity, and then we can see. Containers. I hope, I'm not so sure if it was precise enough in the description that there's not so much, I'm going to say the D word, the Docker containers in this talk. I hope you didn't expect to get a lot of information about Docker containers. That's going to be hard for me to bring because I don't have so much to say about it. Focus is on the containers as we know them from NixOS. As I mentioned, basically systemd and spawn. Whoever tried to run systemd and spawn on a command line? I can recommend this. It was for me helping to understand that how things play together, and basically with systemd and spawn I can basically say I want to run a container that's the root file system, basically, and then I can give it a bunch of parameters to tell it, like this is the IP address I want to connect it to a bridge on the host or some stuff like that. So it's doing a lot of things actually. That's one thing I just can recommend. It's easy to play with it, and it gives you a feeling when you want to understand this stuff, and it helps to navigate between all these moving parts. So then, NixOS containers, there's one important difference, and that took me a while to mentally accept. We have these containers, they are declarative. That is when you configure your NixOS, you describe your attributes. There's one attribute called containers, and inside you can basically describe machines, which are then declarative containers in your NixOS system. But then it's all glued together, basically. And there is this imperative model when you can, on the command line of NixOS, just run NixOS container create, and it's going to throw a container in the right place. It's automatically assigning an IP address. I think in the current state it's going to work for up to about 250 containers, because it's just incrementing the last octet. If I didn't misunderstand the code, but it works quite well, although it's implemented in a fairly simple way. So it's quite interesting to see how that works. But then there is the difference in the imperative containers. It's quite hard to say to get to a point when you want to say, I want this container to have a specific IP address, or I want this container to be assigned to a host bridge. And especially when you get one step further and look at NixOPS. So that was after the first night of heavy crunching things and not wanting to accept the world how it was, I realized NixOPS is actually pretty similar to the imperative model. NixOPS does trigger the machine build, it moves the stuff to the host, and what then happens, it's nearly a code duplication of what the NixOS container script does. It's a bit hard to see because NixOS container is written in Perl and NixOPS is written in Python. That was weird, but I knew both languages, so eventually I got there and I saw, I made a mental note, this is basically the imperative way of putting containers. And then I also was able to somehow accept, okay, they are not having these features that the declarative containers have, and that's why I'm running into these walls here. What I wanted to do, I didn't want automatic IP addresses and all these things. For my case, I thought, as I was developing my application, had like about 30, 40 different repositories locally flying around, and I changed all of them, of course. And I made Nix build an app out of that, but then I wanted to run it in a container because I wanted to show it to somebody else and get a chance so that the other person could play with the application. The other person in that case is more a non-tech person, so it's not the right thing to rsync a bunch of repositories and suggest to run Nix shell and get somehow going. That's not exactly the way how it works. And I didn't want to risk to get into serious trouble because the other person was my wife. She's running, helping me with my business. She's doing the business side, like accounting and taking care of dates and these things. And the application is about some business stuff, so that was not really an option. And yeah, so how do we get the container deployed? Who's done that so far with NixOPS deployed something? Who has tried and failed?
Sometimes.
I don't know. What's your experience so far? It's not about, I don't want to say NixOPS is a good or bad tool, just getting out experience. How did it feel? Like, was it easy? Was it hard? Did you struggle as much as I did struggle, or maybe not? It was easy. I see.
Well,
okay.
The virtual machines are pretty easy to spawn up and so.
Yeah, it depends on the backend.
Yeah, totally.
Yeah. I agree with that. Like with Hetzner, there's some trouble with macOS, and so.
That's also what it's a good macOS. Sometimes it happens to be on some machines. I come to that as well. My experience as well. I think initially I tried to deploy a virtual machine. That's probably the most common starting case. That works fairly well. And then I didn't do anything for a long time because I didn't work on anything that needed a massive cloud deployment, so that was not the case, and I was pretty busy. And then I arrived there with my application and I wanted the container backend, and I realized exactly this point. The backend matters, they are really different. Also looking at the code base of NixOPS, the backends, they have very different level of maturity, I would say, depending on how many people did use them, how many people did run into trouble and tweak things and massage the code until it's really smooth. That's something just to be aware of. It's not because you do it wrong, it's because it's a fresh thing. It's not yet so solid as other backends. That's what I learned about the container backend. Oh my god, what did I do? I pressed the wrong button here. I think I wanted to, maybe I use the space button that's safer than pressing on random arrows. So I mentioned most of the goal already, so I had this existing application. It's called Triton, it has a daemon called Triton daemon, it's about business stuff. It's written in Python, so and I'm sometimes working with that. I'm getting paid working with that, it's an open source thing. But then I thought, since I know it and I have my little business, I could get it a bit more organized, and that's how I came to this application. It's not the typical thing you take for playing around because it's a bit everything that's closer to solving business stuff is somehow modularized and gets complex as an application compared to what I'm usually seeing when I do, for example, web development. So that's the goal. I had the application. I was already able to build it with Nix. That means from this perspective, it doesn't matter what you really have. If you are able to get to build it, that's half of it. The next thing is, if I want to run it as a service, I thought I should have something like a NixOS module. It's not really hard to do this because there are tons of modules in the Nix packages repo, so I just grabbed one as inspiration and made just enough so that I have a service that starts the application. Second thing I needed. Next thing, I want to plug it together with NixOPS, so I describe a network. My network is going to be quite simple because it has only one machine, so it's not exactly a real network. It's maybe a corner case where there's just one machine, but it's good enough to play around with it. So, and I had an existing virtual machine on this Mac. It's based on NixOS, so that was a really suitable target. So that was my idea. So I have a bit of introduction for how this looks like for all people who might be a bit new to NixOPS. Press space. So if I ever go to these arrows, you have to tell me this is space. Otherwise it's gonna be wrong. That's a very simple description of a network. Basically, the way how this looks is we have a little bit of NixOPS specific things. That's what you see around here. It's the network. And then we have something here called, I call it Triton D because that's how the application is called. And what I have in here, this thing here starting from line 4 down to, I believe, 19, that range. This is very similar to how you would describe a usual NixOS machine. There are a few things a little bit different. I think deployment owners, that doesn't exist usually, if I'm not mistaken. And since I hacked around with the application a lot, this stuff has got a little bit more complicated than it would have to be. I basically used 2 different checkouts of Nix packages and so on. This could be quite a bit simpler in many cases. So when you look at this, it's a network. It has one machine. It's called Triton D. Here are the details of the machine. We don't really have to look at them at the moment. So then the way how NixOPS is suggested to work is that you split the logical view from I think the physical view, how you really want to deploy it. So here you don't see anything about the container backend yet. So there is another file which gets combined and it brings these other details. I've made it as simple as possible. Basically I have this option, deployment target environment. And this is now the container backend which I selected. In other cases I could also see there the AWS or the Google App Engine, whatever we have. There is also, I think, a backend called host when you want to directly go to a machine which is already existing.
It's called none.
Ah, okay.
That's the none backend.
The none backend. Yeah, I think host is also used for the machine which you target, so that would not be good to use the same name. I'm just seeing it here because host is here the name of my virtual machine. So that's basically where, in the end, if everything works out, the container should be, and it should run, and it should not explode. And it should get a lot of things the way I would like them to be. We will come to that in a few minutes. So this way, when I use the current NixOPS, if it was not changed during the last months, it would go deploy the container, automatically assign an IP address. It would get the IP address, store the IP address in its local state database, so that I could also, via NixOPS, find out what's the IP address of the container, where is it, it's running, and all these details. So first thing I do to get going is I have to create a deployment. I've again kept, since we wanted to dig into details, I've kept a little bit the dirty way of doing that, or the more complex case. It's the real case that I was facing. Basically, I say NixOPS create to create a deployment. I use the network description. The first file is the logical view. It says there is a machine called Triton-D, but it doesn't say which backend to use. The second file brings in this detail. It says it shall be the container backend, and the target host shall be NixVM1, in my case. And here's additional stuff because I want Nix packages to be my local checkout in that directory, and I had another checkout which I heavily modified, and I didn't want to, I was too lazy to merge it. So I basically made it also available as in the Nix pass, so that I could use it for building the application. And once I've done this, and when I then look into the state, I will see something like this. NixOPS list, I see here every deployment gets a UUID. If you don't do a mistake, you will also get a name. I didn't specify one, that's, I think, not exactly so great, but it's also not a drama. So you could always go via the UUID to address which deployment you want to work with. And as long as you have only one deployment in your database, it's going to use that one. Can also be a bit misleading if you play around and always use just one deployment, and suddenly you get real and you have multiple deployments, then it's important to specify which one you want to target with every command. Yep. Once we have this, nothing did happen yet at this point. So there was nothing built, nothing fetched, no big activity. That's the next step which happens once I call here in the first line NixOPS deploy. That's where the activity starts. That's also where things really start to explode if the details are not yet in shape. Especially when you're on macOS trying to do remote building in a Linux host, that can go wrong. But if you get this figured out, it looks somewhat like this. It starts to build a configuration. You see the typical thing that you would see when you run, for example, Nix build. See that it's going to build a few things. There's going to be a list. It's also telling you that it's maybe, hopefully, going to fetch a few things instead of building them, so that you benefit from the binary cache. And then you see flying by sometimes lines starting with the container name. It's going to create it. It's going to copy the closure into the target host so that it's sitting there in the Nix store. And after a while and a few attempts, once you found out everything, it's going to work out. The activation will successfully finish. That's the theory of operation. If you have multiple machines, they would be thrown out in parallel, in theory, and I think also in reality. And that would be it would be mixed in the output. But yeah, I think that's fairly okay. In my case, that step already was not without trouble, because there seems to be still some issues for the case when you run on macOS and you want to do remote building, because you target a Linux environment. That means the derivations that you want to build, they have to be built on a Linux machine in the end. And Nix does support this. There is this remote systems configuration, but it can be a bit tricky to get this up into a functional state, depending on how you are running Nix itself. If you're, for example, using the Nix daemon versus using the single user mode. I'm using the single user mode, and that's probably why I had it a bit easier to get it running, because it needs to be able to SSH into the target machine and all these details. And I also saw some small issues in NixOPS itself, which I don't remember if we got them fixed already or not. I'm even not sure if I made a PR, or maybe not yet. But there was some minor details to get this into a working state. This is not the case when you are on a NixOS machine. Then it's a bit easier. But those things, they are solvable. It's just, it seems not too many people use it in this scenario. If you look at the bugs, you see more and more people try this, and they all run into this problem. So there's something not yet in the best shape when you want to do this remote building. But I got it working, so it's possible to get there. I think that's also not the hardest part. Okay. That's the first part. I've now two sections about internals. First, I want to look at the NixOS containers, not yet involving NixOPS, just those guys, and see how do they work. Who's involved in creating them? Where does the stuff sit? And how does it play together? Because that was, I think, the second night for me when I found these things, and after a while it started to make sense, and I realized it's not that complicated. It's actually quite simple. It's just spread around a little bit. The context, it's still this container. It's going to be the whole night until tomorrow morning. We are going to talk only about a container called TritonD. There's the first thing I found. Probably many of you know this. When you create a container in etc containers, there's a configuration file. It's just an example. This is not creatable by NixOPS at the moment, only with a few changes which I incorporated already locally. This thing, when you are on NixOS and you say NixOS container create, this script basically goes into etc containers. It's a Perl script. It has a for loop. It checks which files do I have. It tries to get the IP addresses out of it to find out what's the next free IP address. It's very simple and it works. It makes sense. It's the correct approach. But this means there seems to be an implicit contract or API or something like that, which means that we have to record these containers in this place, and then things are going to work. And so I found the script, looked a little bit around inside of Nix packages. At this place, I found the Perl script. And you want me to open it and look at it? I could if you want. But well, the thing is there. What it does, it goes there, it checks in the for loop what's the next free IP address, it assigns it, and then it creates your container, and that's it. So it's a very simple thing. I do believe it also supports by now a few more flags, like attaching a bridge, but I'm not 100% sure. Maybe that I just saw somebody trying to do that, or maybe it's already there by now. But the way how it works is, this script uses Nix to build whatever we need for the machine, for the container. In this case, then it makes this configuration file, and then it can start the thing, because there is, well, now I'm not sure about the terms, but there is for systemd a service template which you can use to run these things. Okay, you're nodding. That's
there is a meta service with an add that's basically reading that file and just running systemd nspawn.
Exactly. So that's the good bridge.
And the declarative containers get their own systemd units basically. So that's the difference.
That's one key difference. So for everybody who did not yet really look at systemd nspawn, based on this configuration file, and this meta unit for systemd, that's more or less the command line that gets executed. An interesting bit, we see, for example, here in line 9, local address setenv, so it's an environment variable, local address and the IP address from this file. We also see that there is potentially something for an IP for the 6 address. Could be there. And something I sneaked in is in line 8, we see host bridge, it's bridge to 0. All this is put into the environment. And I think what you were referring to is created by this module. It basically creates this service configuration, and it gets it also creates the script which is run as a wrapper around init inside of the container. And that script is a shell script. It reacts to these environment variables. That's how it plugs all together. Basically, we propagate the configuration file through this command line, this systemd nspawn, and then we have a shell script that checks what do I have in the environment, and it can react to this a little bit and tweak things accordingly. Apart from systemd nspawn also providing some functionality. Okay, up to that point, or okay. So that is NixOS containers. Once I got there, then I couldn't stop anymore. That's like, I got into it, and that's like, then I have to get to the end. So I put a third line, and I got at the internals of NixOPS. So I wanted to see how does this now plug together. So I understood with this Perl script, this is how NixOS creates containers. It's this configuration file. This feels like being somehow, that's interesting. There is some stuff in there, and that's exactly what I wanted to tweak. So I wanted to know how does it work if I use NixOPS. So I looked then at the code of NixOPS a bit more. It took me a while to get behind the structure. It's very tricky because it's written in a way so that everything can run in parallel. And it has a style which was not so common for me as a Python developer. So it just took me a while to understand that many things are basically triggered in an asynchronous way. And when things are ready and don't have unready dependencies, then they get executed. It's just not as straightforward as calling a function which calls another function. In the end, that's what it does. And once I got there, I got also a high-level understanding of, okay, it gets some resources. In my case, container backend, this doesn't happen. There is nothing except for creating a container, but there's no fancy things around like you would see them in the AWS backend, which can do a lot of things. Then it goes and uses Nix to build all the machines that I defined. And if I build a real NixOS or a container, that's not so much of a difference. It's there is, if I remember correctly, it's basically building one of the attributes in the module configuration. And from that perspective, container or a real system, there is no difference. We just built this, and we have the result in the store. The difference is how we started. What's the next step? And what NixOPS then does, when it really gets into action, it, well, actually not so much action. It basically triggers that this machine and all what's needed for this machine, the closure, is copied over into the target host, so that I get all the dependencies of this particular container into the machine, the host machine where I want to run the container. In my case, that's basically everything needed for a container, plus everything needed for my application, which was also a bunch of stuff. small special thing in my case was remote building on macOS. That caused me some headache, but it is solvable. If I get some time, anytime, maybe next year. I don't know. What I found out, I think I have to put it somewhere. But I also saw some other people trying to tweak it here and there. So I guess that's gonna be better soonish. But especially if you're on your Mac, not running Nix in single user mode, it's somewhat simpler and easier. The best path is still not running on macOS. It's definitely less pain at the moment with that kind of stuff. The way how I got it solved was first get it working just with Nix, then get to the advanced level and try to get NixOPS running. That was a bit tricky. So what do we get out of it? Once I built my network, basically I get this one result. It's a thing called NixOPS machines, and inside of this directory I see some links pointing to the different machines. That was an important insight for me. That first I just noticed it, and after a while I saw that's interesting. I'll come to that later. Also, if there are questions, throw them. Comments, disagreements. So then I thought, how do I get there? To the point what I want. What I want is, I want a container. Yeah. This is something which did work. But I want to decide which IP address, because I didn't want an automated massive cloud deployment. I just wanted to throw an application to a machine. That's a different use case. I think they are both valid. And it seems that my use case was not yet there. So I wanted to give that thing an IP address. Actually, I also wanted to give it an IP6 address, because I wanted to play with that, but also not easy. Then I realized actually I wanted to make this thing available, because I wanted to reach it from my network in the office. So I thought if I could get this to a bridge or something like that on the host, then it's maybe easy. Yeah, that's basically what I want. And if you look around, you see when you look at the manual of NixOS, and there is this appendix with all the configuration options. And then when you look at the section with containers, with the declarative ones, all these options are there. It's fantastic. I just wanted them for my case as well. I thought, yeah, well, they are split for a reason. I will not be able to do that. Crazy idea. Yeah, and I kept thinking, thought, why not? If I could write, this is my container, and I could say there's backend specific options, then I could suddenly describe, it's not containers, it's singular, it's container. I could say, I want this container to have a specific configuration file which I decide on. Nobody automatically, I want to decide that. Handcrafted, for my case, only for my case. And I thought, okay, I want this local address, host address. I want to be able to say I want bridge interface. The problem with these bridge interfaces is, if I remember correctly, it works nice when it's in this container configuration, because when you bring the container up and down, it needs to be attached to this bridge interface. Otherwise, if you manually do this, when you bring it down and you bring it up again, it's not attached anymore. You would have to manually take care of this. So on the other side, with these declarative containers, it just works already. So then I thought, maybe I can do this. I always wanted to learn more about the module system and stuff like that. And yeah, pulled in basically another night. I came up with this. Also, I have made a comment with a link on some issue somewhere on GitHub, and yeah, that was it. Maybe we look at it later if you want. That's you did see it already in the very beginning. It was the first thing on the screen. My proud result after 3 nights of hard work, going crazy. Let's look from a different perspective. The desired output. When I build a machine, I get this pointer here next door, blah 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 blah, and Triton D. That's my container. That's where I want to be. And there is everything in there what we expect to be in there. Stuff for system D. I believe that something here is with the profile, the init script. Switch to configuration, activate. All these things play a role in plain NixOS. That is when you rebuild your machine and switch. These scripts are used to actually carry out the switch. And I thought, cool, maybe I can put the container configuration here. Then I would have it in the package and it could be shipped to the host. And actually, I would not have to change too much NixOPS because I didn't understand the code at that time fully yet. And this is a result of plain Nix. That's what Nix spits out at the end. What I did have to change in NixOPS was to tell it, okay, when you deploy a container, and let's see if I find it. And if there is this option here, right, container config, then I want you to look for this file, and instead of writing something that this Perl script would write, copy this file to the place. That was my idea, and I thought, how cool. And then I had this crazy idea, maybe that could be a path, maybe not exactly this way, but it could be a path how we could look at unifying these imperative and declarative, damn it, it's a too long day already for me, how we could unify these containers slightly. Because in the declarative case, it's easy to build this configuration because all the information is there in this when this thing gets built. When I build a container in the imperative way, I need this configuration to be inside of this container somehow. Otherwise I cannot, there is no outside in this case. And by putting the file there, I thought, maybe even this Perl script could understand this, and if there is this file, instead of applying the automatic way, it could go and say, okay, if he wants this file, I copy it there. And the responsibility for putting something reasonable into this file, it's not with this Perl script, it's with the one who decided that he wants a custom file there. I think that would be a fair deal. If you tweak things, you're in charge. You can't blame any other script anymore. Yeah, that's basically where I arrived in the end. And that is mainly it. Except if you want to look at some code, but I could also throw it somewhere on the meetup thing, and you could dig around as much as you want and also as deep as you want. There are some pointers. They are in reverse order to the pointers that I'm showing tomorrow morning. Because what was helpful for me was the NixOS menu is fantastic, especially these configuration options. That helped me a lot. The NixOPS menu, at the moment, I struggle with that, to be honest. I even didn't come up with a good way of making it better. I was not yet there, maybe at some point. And also the other two menus. In the end, I needed everything to get to a point where I had this feeling of, I had this 1 hour where I thought I was understanding it all for a moment. Yeah, the code, it's thrown somewhere. Especially my hacks. are also, they are only in my fork. But I'm not brave enough to make a pull request, so maybe I should create one and write something nice that it's there for people who are interested. All these things were used by me to start to understand this. Yeah, community. In general, the NixOS community is great. I mean, you probably know that. It's fantastic. It doesn't matter to which conference on something somehow related to open source you go, there are always some crazy people who have nice stickers on their machines, like that one. The new one, I only have this very old one. Yeah, it needs a renewal at some point. But that's really fantastic. But once you get to NixOPS, it seems there are people making heavy use of it. They seem to be super busy, and it's really hard to get through these first 3, 4, 5 boards. Once you're through, then it's easier, I would say. That's so that was my journey. They made it. I don't know if there are questions or things.
So, just a few comments. The thing is, with NixOPS, probably most people are using the non-backend and just SSH into machines for production deployments. So that's probably the best tested one. So that's basically for it's the most simple one. To the container stuff. Unfortunately, the NixOS container infrastructure is largely unmaintained. There haven't been much changes in the last year. That's very unfortunate. And the other changes of like the host bridge, and we have a lot of new options in there. For example, for devices you want to have available in the container, which just add more code, but the whole thing should be refactored. So I welcome your approach to unify imperative and declarative containers, but I think it's not that easy. For instance, what options do you support in the container module? Are you importing all options that are available? Because the problem is, some options are passed via environment variables into the systemd nspawn container, and some options modify the systemd nspawn call. And in that case, you can't use that container config and then use that for imperative containers.
Yeah, I guess so, especially the part which you mentioned when you use a declarative container. The systemd nspawn unit, this file is adjusted.
Yes.
And the points which are adjusted there, that is not possible at the moment to emulate this. So that would need a rewrite mainly.
Yeah. So basically the feature set of imperative and declarative containers have diverged, and now we have the problem that we have some features available in declarative containers that you haven't available for imperative containers. So yeah, we should rewrite that at some point.
From my perspective, I totally agree. I have so much respect for this thing. I mean, that's one of the things, usually, so for me it's like I really enjoy digging into new things, and sometimes I'm usually not taking that long to start to understand a thing. And it seems that the container stuff, it's really hard to get all the pieces together. And I'm afraid that also makes it so hard for anybody to start to get productive or to provide something or contribute something, because it's really there are some walls that you really need to cross. There's no easy way. That's really hard.
So the reason is probably that there are not many users of the container NixOPS backend, unfortunately, but I will probably need that anyway in a few months. So. We should work on that. Another issue I had is when you use declarative containers, the whole host Nix store is mounted into the container Nix store. So if you happen to have secrets in your Nix store, you have all of them available in every container, and they are world readable. So I have little hack in our fork that so you can only the store paths that are needed are mounted into the container. But that's another it's a hack. So I didn't get it upstream yet.
It's definitely it's a very relevant point, I think.
Yeah.
So that there is just containers. How I understand them currently, they are convenient for things which I just presented, because I had a host system which is more or less stable, and I wanted to quickly throw something else, and so I want to be able to partition that I want to avoid that these things get mashed up. I didn't want them to be so tightly coupled from the handling perspective. And I had this idea since we often jump between in my little company, we jump between different projects, and it would be so handy to be able to do such a thing, to quickly throw something for somebody, and not having to use just a different technology, but playing Nix would be so cool, because we use that day to day for Nix itself, and that would be fantastic. But yeah, at the moment, I see there is some work needed and some ideas needed how to do some progress there. But I definitely see, from my perspective, I'm still excited about that. If we would get this figured out, it would be of a lot of value. For me, it would, for example, for my personal need, be good enough as a replacement for all these other fancy things that I'm sometimes forced to use. Yeah. Oh my God, it's so quiet. That was the missing signal. Now it's over. Get chatty.
What about restricting how much memory or CPU is used by the containers? Did you look into that?
I think by accident, and I hope maybe someone can tell me if I'm right or wrong. I think currently there is not too much support of that. The question is, it's how I understand it, if systemd nspawn supports something, then we could make this available if we implement a way of telling systemd nspawn what we want. That is basically the question. How do we pass this parameter through? And the critical part is how to make it so that these different container things do not further diverge, but start to converge, so that we avoid that people get lost because they see something for declarative containers and they think, this should work, and they try to use it for imperative ones, and then they get frustrated. I think that's a tricky part, but in my opinion, it boils down to passing a variable through.
But I just looked. Systemd nspawn doesn't support that. So what I would do is create a slice in systemd and just put the container unit into that slice. That would work. But of course, you would have to know the systemd internals for that. It's not an option for the container. You have to do like systemd.slices.name and then override the container service to run that slice. So it works. It's probably only 2 or 3 lines, but you have to know stuff.
And what about C groups? Could you?
That you would do that in the slice. So the slice is the systemd abstraction for resources, basically for resource management.
And then nspawn would run inside of that.
Yeah.
Right? Yeah.
Okay.
So
It's kind of a label where you just put some process on top.
So you basically can restrict the nspawn process and its children in the same way as every usual process.
Exactly.
Yeah.
Cool. Yeah.